A conic is the curve you get when a flat plane slices through a cone. On screen, picture a full three-dimensional cone standing upright. Now watch the cutting plane tilt to different angles, still in 3 dimensions. As the angle changes, the flat slice it leaves behind flattens out into a 2-dimensional curve, and that same running picture updates to show it. When the plane cuts straight across at a gentle angle, the slice becomes an ellipse. When the plane cuts exactly parallel to the side of the cone, the slice becomes a parabola. When the plane cuts more steeply than the side of the cone, the slice becomes a hyperbola. Eccentricity is a number that tells us how stretched a conic is compared to a perfect circle. A circle has an eccentricity of 0, and the more stretched the curve becomes, the larger this number gets. Worked example, Part 1, the standard form of a parabola. In words, the standard form says y squared equals 4 times a times x. Feature 1, the vertex. For this standard form, the vertex sits at the origin, the point where x equals 0 and y equals 0. Feature 2, the focus. The focus sits on the x-axis at the point where x equals a and y equals 0. Feature 3, the directrix. The directrix is the vertical line where x equals negative a. Worked example, Part 2, the eccentricity of an ellipse. In words, eccentricity equals the square root of 1 minus b squared divided by a squared. Take an ellipse where a squared equals 25 and b squared equals 16. Inside the square root we get 1 minus 16 divided by 25, which is 9 divided by 25. The square root of 9 divided by 25 is 3 divided by 5, so the eccentricity equals 0.6. Check step for the ellipse. For any true ellipse, the eccentricity must be greater than 0 and less than 1, and 0.6 does satisfy that, so the answer checks out. Worked example, Part 3, the eccentricity of a hyperbola. In words, eccentricity equals the square root of 1 plus b squared divided by a squared. Take a hyperbola where a squared equals 16 and b squared equals 9. Inside the square root we get 1 plus 9 divided by 16, which is 25 divided by 16. The square root of 25 divided by 16 is 5 divided by 4, so the eccentricity equals 1.25. Check step for the hyperbola. For any true hyperbola, the eccentricity must be greater than 1, and 1.25 does satisfy that, so the answer checks out.